Hello, in this video we're going to introduce the multiplier approach to analyzing how shocks to aggregate demand affect aggregate output. This video is part of Chapter 10, Part 10.4, Learning Objective 10.4. Now, very often in macroeconomics we want to tell stories. We want to tell stories about how changes to expenditure in one sector or one group of economic agents ripples through the economy, spills over, has what we might call knock-on effects, and ultimately has effects on the aggregate output gap. So, for example, we might think of changes to consumption by households, changes to investment by firms. These are shocks that we learned about in previous chapters. But let's take an example. In the chapter, the further to the point talks about the revival of the U.S. housing market. In the U.S., as was the case in other countries, low and falling housing prices were, to some degree, responsible for poor economic performance, low output growth for several years. When housing prices were stagnant, people spent less. However, around 2012, the situation began to change. Housing prices began to recover, and for a number of reasons, people began to spend more. Now, one of the direct impacts was that as housing prices began to increase, more houses were built. That meant that companies hired more people to design and construct new houses. So you can see that these people who were designing and constructing new houses, they had some more money in their pockets. But then we might want to think about the indirect impacts, or sometimes people might think of it as ripple effects, as if we are throwing a pebble into a pond and then the pond is having ripples. So we think about the construction workers who are now back on the job. They need reliable transportation, so they're going to purchase more trucks. So that means there's going to be more income, let's say, to automakers and to the employees of automakers, who in turn are going to spend more. Also, when people go and buy these new houses, the new homeowners, they're going to have to purchase furniture, appliances. They're going to have to make their gardens pretty, landscaping materials, and all of these providers of these goods and services, furnitures, appliances, landscaping services, they're all going to benefit. They're all going to have some extra money in their pockets, and they're going to be spending that money as well. That's the kind of indirect or ripple impacts that we often talk about. So in this section, we're going to find a way to analyze a little bit more formally these ripple effects. And we're going to also be looking at what is known as the multiplier effect. And what the multiplier effect tells us is that the impact on economic activity at the end of the day can be larger than the initial shock itself. So that initial shock, we say, is multiplied as it ripples throughout the economy. Now, this multiplier effect, this magnification of a shock, only happens under certain circumstances. And one of the circumstances that we're going to assume is that prices are assumed to be fixed. Because it turns out that if we have flexible prices, some of these multiplier effects can be damped and can be choked off. So let's think of a warm-up analysis. This is the analysis in the book. And we think about people whose house value has risen, and they decide to spend 1% more of potential output. We're going to call that AUT-C. The autonomous shock to consumption is equal to 1%. And let's suppose that potential output is 14 trillion. So that means the initial amount of that spending shock will be 1% of 14 trillion. That's 140 billion. We think of that as the first round, the initial impact. But there are going to be subsequent rounds. The second round, the people who receive that 140 billion, they're going to be spending some fraction less than the original 140 billion. Why? because what we learned is that when people receive transitory income, and this is a kind of a transitory income, this is not long run, they will spend some of it and they will save some of it. We're going to use the terminology sigma sick, which we learned in a previous chapter. This is the marginal propensity to save out of transitory income, and then 1 minus sigma sick is the marginal propensity to consume out of transitory income. So let's think of sigma sick, for example, as being 70%. That means that the marginal propensity to consume will be 1 minus 70%, which is 30%. So people will be spending that extra 30% of the original 1% of potential output. Then in a third round, people will be spending 1 minus sigma sick times 1 minus sigma sick, or more compactly, 1 minus sigma sick squared times the original 1%. Now notice that this is a smaller fraction, because if this is less than 1, something that's less than 1, and if you square it, it's going to become smaller. Let's think of the third round, the fourth round, and the fifth round. The increases in spending are going to become progressively smaller and smaller and smaller. So we'll have 1 minus sigma sick to the third, 1 minus sigma sick to the fourth, etc., etc., etc. So now what we're going to do is we're going to go to a spreadsheet. So here we have all of the data. Okay, we have the propensity to consume out of the output gap, and we're thinking of the output gap as transitory income for households in the aggregate. So that's 30%. So sigma sick is 0.7 or 70%. We also thought about potential output, and we just said it was $14 trillion. That's a nice round number. And our initial shock was 1% of potential output, or 140 billion. So now we're going to call that initial shock AUT-AD, the autonomous shock to aggregate demand. Now we're talking about this as a household spending shock, but it turns out that we could apply this to other sectors of the economy. That's why we're using this more general notation of AUT-AD as an autonomous spending shock, 1% of potential output, or 140 billion. And we assume that in each successive round of spending, households will spend 30% of what they had previously spent. So in the second round of spending, we're going to have 30% of the 1%, or 0.3%. In dollars, that's 42 billion. By the way, this spreadsheet is available to you so you can verify these calculations. In the third round of spending, we're going to be spending 30% of the original shock, or 0.09%. That's $12.6 billion. In the fourth round of spending, we're going to be spending 30% of 30% of 30% of the original 1%, or $3.8 billion, and so on and so on and so on. I think that you get the idea here. And you'll notice that after several rounds of spending, the amount of spending gets smaller and smaller and smaller and smaller. Now over here in these columns, we've taken the cumulative impact. We've added things up. So in the first round, we had 1%. The second round, it was 0.3%. So now the cumulative impact is 1.3%. In the third round, the impact was 0.09%. So the cumulative impact is 1.39%. In the fourth round, the impact was 0.03%. So the cumulative impact was 1.42%. And in this fourth round, the impact was 0.01%, or the cumulative impact adding up would be 1.43%, and you'll notice that we level off here at 1.43%, and that's not a coincidence. I'll be explaining that in a second. Now here we have billions of dollars $140 billion, and we add on that 42 and we get 182. Then we add on the extra 12.6 and we get 194. And then we get, with another 3.8, we get 198.4. With another 1.1, we get 199.5, etc., etc., until we top out here at 200. And once again, that's not an accident. So we find that our initial shock of 1% has meant an increase in total spending that has rippled through the economy that is greater than that initial 1%. It's 1.43%. In billions of dollars, we can see that initial $140 billion was rippling through the economy and ultimately ended up increasing spending by $200 billion. So once again, you can verify these shocks and do the arithmetic. Now, there's something that you may have learned, and that's what is known as an infinite series. And an infinite series tells us that if we take some number x, and let's assume that the number x is between 0 and 1, and if we take the sum of x to the 0th plus x to the 1st plus x to the 2nd plus x to the 3rd and so on, we will end up with an algebraic solution for the infinite series for 1 over 1 minus x. Well, it turns out that that's exactly what we have here, because we can think of 1 minus the cyclical propensity to save, 1 minus sic. We can think of that as x, and we can think of multiplying this as 1 minus sic to the 0th, 1 minus sic sigma sic to the 1st, 1 minus sigma sic to the 2nd, 1 minus sigma sic to the 3rd, etc., etc., etc. And you can solve it out, and you can find that's going to end up being 1 over sigma sic. So you can see now that the full effect of the original shock will be that shock multiplied times 1 over sigma sic. So 1 over sigma sic is our first multiplier. Once again, what we've learned is we've learned how some initial shock, in this case 1% of the economy of the potential output, or $140 billion, can be spent over and over and over and over again, the ripple effect rippling throughout the economy, and assuming that prices are fixed, and therefore price increases don't dampen these spending effects, the ultimate result will be an increase in spending that exceeds the original shock. This is the multiplier effect. And in billions of dollars, we found out that we started off with an initial shock of $140 billion, and guess what? After successive rounds of spending, the final impact was $200 billion. So, in the next video, we're going to answer a question that you may be asking to yourself. How do we know in this analysis that at the end of the day, aggregate output equals aggregate expenditures? Because it has to. Supply has to equal demand. Well, we're going to show that that must be the case, but we're going to do that in the next video.